Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. After studying about theory of attributes, tests of significance, large sample test, small sample test, sampling distributions of mean, proportions and variance, we have been discussing order statistic in the previous session. We have derived the CDF and PDF of smallest and largest order statistic. Also in general, CDF and PDF of rth order statistic was also derived. In continuance with the order statistics topic, in this session we will be working out some problems in order statistic. So, the first example goes like let x1, x2, x3 etc. up to xn be a random sample from a population with continuous density. Show that y1 is equal to minimum of x1, x2, x3 etc. up to xn is exponential with parameter n lambda if and only if each xi is exponential with parameter lambda. Okay. First of all, we have to prove that y1 is equal to minimum of x1, x2 etc. up to xn is exponential if xi is exponential with parameter lambda. And assuming the minimum of x1, x2 etc. up to xn is exponential, we have to prove that each xi is exponential with parameter lambda. Okay, we shall prove this. First of all, let us assume that each xi is IID random exponential random variates exponential variables with the parameter lambda. Then to prove yi is equal to minimum of x1, x2 etc. up to xn. So, order statistic y1 is equal to minimum of x1, x2, x3 etc. up to xn is exponential with parameter n lambda. N lambda. Okay. So, first of all take xi. Since all xi's are IIDs, all will be having the same PDF and CDF. Therefore, in common we shall take it as x. Therefore, fi of x is equal to f of x for a particular random variable xi. The PDF is given by the exponential distributions PDF lambda e power minus lambda x given for x is greater than or equal to 0 and then lambda is greater than 0. Okay. Then what about capital F of x? Capital F of x is CDF of x, which is p of x less than or equal to x, which is equal to integral u is equal to 0 to u is equal to x f of u du, which is integral 0 to x lambda e power minus lambda u du. Then integrating we get 1 minus e power minus lambda x after substituting here. Okay, after substituting, this is capital F of x. Okay. Then the distribution function of y1, that is distribution function of y1 we have to consider now. function of y1 is g of y1 is equal to, what is y1 actually? y1 is a minimum of x1, x2, x3 etc. up to xn. So, since it is a distribution function, it is g1 of, we will write g1 of y is equal to p of y1 is less than or equal to y. y1 is nothing but minimum of x1, x2 etc. up to xn is less than or equal to y. Since minimum of x1, x3 etc. up to xn is less than or equal to y, it is the smallest order statistic. For smallest order statistic, the PDF is given by 1 minus of f of y whole power n. This is by equation 3. Just refer in the previous session, this is by equation 3. So, our f of y is 1 minus of 1 minus lambda x. So, 1 minus of e power minus lambda y whole power n. This 1 gets cancelled and you will have only 1 minus e power minus n lambda y. This is the CDF of y1. Okay. Then the PDF of y1 will be is given by g of y1, which is the derivative of the CDF. Okay. The derivative of CDF is n, which actually it is 1 minus e power minus n lambda y. Therefore, we will be having its derivation as what is the derivation of 1 minus e power minus lambda n y? Derivation of 1 is 0, e power minus n lambda y becomes minus n lambda into e power minus n lambda y. Already one minus is there, which is n lambda into e power minus n lambda y. Okay, this is the PDF of y1, which is actually the PDF of exponential distribution with parameter n lambda. In the place of lambda, we are having n lambda. For y greater than or equal to 0, n is greater than 0 and lambda is greater than 0. Okay. Hence, we have proved if xi is taken as exponential distribution with parameter lambda, then y1 is equal to minimum of all such xi's will also have a exponential distribution with parameter n lambda. Now, conversely, assume that y1 is equal to minimum of x1, x2 etc. up to xn is exponential with the parameter n lambda. To prove each xi is exponential with parameter lambda. Okay. So, what is given? We have p of y1 less than or equal to y, which is the CDF of y1 is 1 minus e power minus n lambda y. Okay. So, that p of y1 greater than y will be 1 minus of p of y1 less than or equal to y. Okay, which is 1 minus of 1 minus e power minus n lambda y, which is e power minus n lambda y. Okay. Now, that is we are saying that minimum of x1, x2 etc. up to xn greater than y is equal to e power minus n lambda y. Okay. It means to say that p of x1 greater than y intersection x2 greater than y intersection etc. xn greater than y is equal to e power minus n lambda y. We mean to say that p of x1 greater than y, because of the independence p of x2 greater than y etc. p of x n greater than y is equal to e power minus n lambda y. It is like multiplication of I is equal to 1 to n p of x I is greater than y is equal to e power minus n lambda y. Okay. So, this implies p of x I greater than y, because of identity all are same, whole power n is equal to e power minus n lambda y. E power minus n lambda y is written as e power minus lambda y whole power n. Just cancelling the power on both sides or raising to the power 1 by n on both sides, we have a p of x I greater than y is equal to e power minus lambda y. So, that p of x I less than or equal to y is equal to 1 minus p of x I greater than y is equal to 1 minus e power minus lambda y, which is actually this is the CDF of exponential distribution with the parameter lambda. Okay. Hence, we have proved if y1 is equal to minimum of x1, x2, etc. up to xn follows exponential distribution with parameter n lambda, then each xi from which the minimum has been taken as y1, each xi follows exponential distribution with parameter lambda. Hence, proved. Next, for the exponential distribution f of x is equal to e power minus x for x greater than or equal to 0, show that the cumulative distribution function of xn, that is the largest order statistic in a random sample of size n, is fn of x is equal to 1 minus e power minus x whole power n. Hence, prove that as n tends to infinity, the CDF of xn order statistic minus log n tends to the limiting form of exponential of minus e power minus x, where minus infinity less than x less than infinity. The solution given f of x is a exponential distribution with parameter 1 for x greater than or equal to 0. Then according to the formula fn of x, before that what is a capital F of x? Capital F of x is p of x less than or equal to x, it is integral 0 to x f of u du. We have just proved this in the previous problem. So, capital F of x is 1 minus e power minus x, okay. And by the equation 2 in the previous session, CDF of the largest order statistic is given by fn of x is equal to p of xn less than or equal to x is equal to f of x whole power n. This is equation 2. F of x whole power n, that is equal to here accordingly you will have 1 minus e power minus x whole power n. So, the first part of the problem is proved, that is the CDF of largest order statistic for a exponential distribution is fn of x is 1 minus e power minus x whole power n. Okay. Next, we have to find out the CDF of variable x n minus log n. Okay. X n minus log n, which is given by g n of x is equal to p of x n minus log n is less than or equal to x. Now, in the place of x you are having x n minus log n, which is p of x n is less than or equal to x plus log n. Just look at the previous one, that is fn of x. In the place of fn of x you are having fn of x plus log n, right. So, this is fn of, in the place of x you are having x plus log n, x plus log n which is 1 minus e power, what is that, fn of x. Fn of x is 1 minus e power minus x whole power n. In the place of x you are having x plus log n. Okay. Therefore, e power minus of x plus log n the whole power n, and this is written as 1 minus e power minus x into e power minus log n whole power n. E power minus log n is 1 minus e power minus x e power log of n power minus 1 the whole power n. E power log of n power minus 1 is 1 by n. So, it is written as 1 minus e power minus x by n the whole power n. This is equal to e power of minus e power minus x. Since 1 plus m by n whole power n is equal to e power m as n tends to infinity. So, here also it is equal to e power minus x as n tends to infinity. Okay. So, hence we have proved that the CDF of x of n minus log n is e power minus of e power minus x, that is exponential of minus exponential of minus x as n tends to infinity. Hence proved. Next example is show that in odd samples of size n from a uniform distribution having parameters 0 and 1 population. It means the population is following uniform distribution with parameters 0 and 1. The mean and variance of the distribution of median are 1 by 2 and 1 by 4 into n plus 2 respectively. We have to prove this for odd samples of size n. First of all, we shall write down the PDF of the population. PDF of x is f of x is equal to 1 by b minus a. It is 1 by 1 minus 0 for 0 less than or equal to x less than or equal to 1. So, therefore, f of x is equal to 1 for 0 less than or equal to x less than or equal to 1. Okay. And what about its CDF? CDF of x is capital F of x is equal to integral 0 to x f of u du is equal to 0 to x 1 du, and this is x, capital F of x equal to x. Okay. Now, we are going to talk about odd samples, right. Therefore, let n is equal to 2m plus 1, that is odd, where m is a positive integer, greater than or equal to 1, the median observation is that is the median rth order statistic. This is median observation is x m plus 1. Next, taking r is equal to m plus 1 in the PDF of rth order statistic. PDF of rth order statistic is given by rth order statistic fr of x is equal to 1 by beta of r comma n minus r plus 1 into that f of x whole power r minus 1 into PDF f of x into 1 minus f of x whole power n minus r. Now, substitute for r as m plus 1 and capital F of x, that is CDF for this distribution as x, and f of x is 1 and capital F of x is again substituted as x. So, substitute r is equal, everything has to be done simultaneously now. 1 by beta of m plus 1 comma n is taken as 2m plus 1, right. So, 2m plus 1 minus m plus 1 plus 1, okay. And f of x is x, at the same time r minus 1. So, m plus 1 minus 1, small f of x is 1 and 1 minus x whole power n is 2m plus 1 minus r is m plus 1. Okay. So, that becomes 1 by beta of m plus 1 comma 2m plus 1 minus m plus 1, this 1 gets cancelled and 2m minus 1 m is m, and then it becomes m plus 1 along with this 1. Okay. So, x power m and then 1 minus x whole power m. This is f r of x now. Okay. For the median observation, that is, we have now just arrived f m plus 1 of x is equal to 1 by beta m plus 1. 1 by beta m plus 1, we will use the formula of beta of m comma n. Formula is gamma m into gamma n by gamma m plus n. So, using this formula, we will just write it here, 1 by gamma m plus 1 into gamma m plus 1 divided by gamma m plus 1 plus m plus 1 into x power m into 1 minus x whole power m. So, this is actually gamma 2m plus 2 divided by gamma m plus 1 into gamma m plus 1 into x power m 1 minus x whole power m. Okay. Now, we shall find out the mean. We have just arrived at the PDF. This is the PDF of x m plus 1. Okay. Now, the mean of x m plus 1 observation is expectation of x m plus 1 according to the formula is x into f of x m plus 1, okay, dx, and this is equal to integration x into, just write down all the formula, we will just found out gamma 2m plus 2 by gamma m plus 1 whole square into x power m into 1 minus x whole power m dx, and the limits are from x is equal to 0 to x is equal to 1 because of the uniform distribution. Okay. This is equal to integral 0 to 1, all those things can be taken outside first of all, equals to gamma 2m plus 2 by gamma m plus 1 whole square. So, x power m plus 1 into 1 minus x whole power m dx, and this is the beta formula. What is beta of m comma n formula? Beta of m comma n is integral 0 to 1 x power m 1 minus x whole power n dx, x power m minus 1 into 1 minus x whole power n minus 1. This is the formula of beta of m comma n. So, here you will be having gamma 2m plus 2 by gamma m plus 1 whole square written as it is. In the place of m minus 1, you are having m plus 1. For formula, it becomes m minus 1 means it becomes m here, that is 1 has to be added here, and similarly if it is n minus 1, 1 has to be added with n minus 1 to become n. You will be having m plus 1. So, it becomes beta of m plus 2 comma m plus 1, which is equal to gamma 2m plus 2 by gamma m plus 1 whole square into, according to the formula, it is gamma m plus 2 into gamma m plus 1 divided by gamma m plus 2 plus m plus 1. Okay. So, that becomes equal to gamma 2m plus 2 by gamma m plus 1 whole square into gamma m plus 2 gamma m plus 1, 1 gamma gets cancelled, gamma 2m plus 3. Gamma m plus 2 is written as first of all gamma 2m plus 2 is written as gamma 2m plus 1 factorial. Actually, gamma n is n minus 1 factorial. Okay. So, gamma m plus 2 is m plus 1 factorial and gamma m plus 1 is m factorial. Gamma 2m plus 3 is 2m plus 2 factorial. Okay. And for cancellation, we shall write the things appropriately. 2m plus 1 factorial is as it is written, m plus 1 factorial is written as m plus 1 into m factorial divided by m factorial is written as it is, and 2m plus 2 is written as 2m plus 2 into 2m plus 1 factorial. Okay. So, 2m plus 1 factorial gets cancelled, m plus 1 factorial gets cancelled, and if you take 1 by 2 outside, m plus 1 by m plus 1 gets cancelled, and you have only 1 by 2. That is the mean of a median observation. Observation is 1 by 2, we have proved. Next, to find the variance, we need E of x m plus 1 whole square observation, which is integral x square into f of x m plus 1 dx, and it is integrated in the usual format, substituting all the things, integral 0 to 1 x square 1 by gamma 2m plus 2 by gamma m plus 1 whole square into x power m into 1 minus x whole power m dx. Like continuing in the same fashion, we will end up with this format, beta of m plus 3 into beta of m plus 3 comma m plus 1 into gamma 2m plus 2 by gamma m plus 1 whole square. Now, beta m plus 3 written in the format of gamma m plus 3 into gamma m plus 1 by gamma 2m plus 4 into gamma 2m plus 2 by gamma m plus 1 whole square. Now, after simplification, this ends up with m plus 2 by 2 into 2m plus 3, that is E of x square of m plus 1. So, for variance, variance of x m plus 1th observation is equal to expectation of x square of m plus 1th observation minus E of x m plus 1 whole square, that is m plus 2 by 2 into 2m plus 3 minus 1 by 2 whole square, and this answer comes to be equal to 1 by 4 into 2m plus 3. Substituting for n as where we have taken n is equal to 2m plus 1. So, m will be n minus 1 by 2. So, that you will be having 2m plus 3 as n plus 2. So, 1 by 4 into n plus 2, that is the variance of x m plus 1th observation, which is the median observation. In this session, some problems have been worked out in order statistics. In this session, we have worked out some problems in order statistic, where we have worked out some problems related to verifying the PDF of one order statistic, that is minimum of x1, x2, etc. up to xn as the exponential distribution, and the corresponding random variable is also exponential. Like that type of problems we have done in this session. So, based on discussion in this session, this following question may be posed. Show that for a random sample of size 2 from a normal distribution with mean 0 and variance sigma square population, we have to prove that the expectation of the smallest order statistic is minus sigma divided by root of 2 pi. Thank you.